Okay, so I focus a small presentation on the leitmotif of the session. It was about good neighbors. Okay, so we talk about good neighbors, interfaces, difficulties, and solutions. Let's say. So the question is: are rolling stock suppliers really good neighbors? Are we good neighbors or not? I could say that we are really contractually good neighbors. We respect the contract. That's our objective. Okay, that's our definition of good neighbors. But as good neighbors, okay, we have to be flexible. We have to live in community with our friends, our neighbors from the downstairs, from etc. etc. So we need to be happy in good harmony. Let's say. Okay, and what is our main relation with our main neighbors? So it's mainly about exterior noise performances, standstill noise, parking noise, pass-by constant speed, acceleration noise, warnings. Okay, I didn't put curve squeal, but could be also there. And our community is wide, so we are not alone. So we depend a lot on operators, on infrastructure, in the policymakers, and in people. At the end, we do all this to have a good system for people, not for us. Let's say. And we could say we are a community. So we are in Paris. Okay, I'm a fan of Sempe, of Petit Nicolas, and I found this image, and I think it represents a little the situation we have today. We have a little boy, Petit Nicolas, with a trumpet. Okay, the trumpet is the supplier. The trumpet alone doesn't make any noise unless an operator, Petit Nicolas, is going to blow on it and make some noise on that. Okay, and of course there's an infrastructure. We can see here there's some trees that could help a little to attenuate the noise. And we have all the residents, that all of us, we are the neighbors looking at that, hey, what this train is doing. And we have a policymaker that is shouting a lot, saying, hey, what are you doing? We have to respect the levels. So this is just to say that we are not alone in this world, okay? The final noise performance depends a lot on the complete community for all of our activities. And if we make a synthesis, for example, for pass-by noise, we are totally dependent on the infrastructure. So track quality. Track quality is the key. We could say also that the howling loads that we have on a train could affect to exterior noise. That depends mainly on the way it's operated a train. Okay, for standstill, we are less dependent of the infrastructure. So the train alone is really the noise source. So we don't depend on the infrastructure. For parking mode, which is a kind of a standstill in specific conditions, we are very dependent on the operator needs. So depending how they're going to operate the train during the parking or energy mode, we could call it. And for acceleration, it depends also on acceleration on operator needs, acceleration rate, loads, etc. So at the end, these are more or less our interfaces with the world, let's say, and how we depend or how we should relation between each other. So what are the difficulties to be a good neighbor? Okay, the main thing is the definition of good neighbor is not always the same, okay? Because we're not talking with the same neighbors, okay? So we have a lack of standardization. We have the difficulty to develop products that they are good for all of our community, making the same system will make the things cheaper. And today is not the case because every customer demands different targets. Okay, we have multiple different requirements in function of the operator, and we could have multiple ways of operating a train, especially for parking noise. Okay, so we are good boys in front of policymakers. Let's say we try to respect. We respect the TSI noise. But we think that in real operation, we are not visible, okay? So you still being compliant to TSI noise doesn't mean that you can compare the noise performance of train A from train B, because today the standards doesn't allow to show still for pass-by noise the quietest train. So the definition of a standard track, we think that is not still good enough, let's say. And I give you the example of parking mode. So we have different operating conditions. Okay, we could find today in Europe or standards, let's say Euro spec. Okay, that is built by some operators. BDV 1541, that is the association of of operators in operators in Germany that propose a standard for parking mode, and then we find also a specific requirements for parking mode from different customers. So, and we don't have today. We will have. We expect soon. Okay, in a couple of years, a new ISO standard that will try to define how we should make the measurements. But we have to be sure that this new standard will also define in some way how the vehicle should be operated in order to have comparable measurements. But for us, the most complicated for us is to be comparative, because when we are in a tender, we are in a competitive world, and proposing, I don't know, 60 or 55 could change a lot the game, and it's very important for us. And if we are not able to compare similar situations, it's complicated for us to propose standard products. So as a summary, okay, especially for parking mode, there's a lack of standardization. And in generally speaking, for pass-by, the quiet trains are not visible today. So I give two examples only for pass-by and parking mode. So for pass-by, okay, pass-by, exterior noise pass-by. So we could say that we are close to the technical limit up to 200 kilometers per hour. Why? Because the main contributor is the track. So whatever we will do on the train, really improving the noise of the motor or something like that, or adding skirts or something like that, will not improve the situation, okay? So there's some examples here of, I don't say the pointer. Can you see the pointer? Pointer laser. Okay, so that's it. Okay, so regional train at 8 kilometers per hour. This is just an example, okay? The contribution is around 60%, more or less, while the wheels are 15% and the drive, motor, gearbox, and some equipment is around 23 at 80. We go up, raise the speed up to 200. The contribution of the track is 43, the wheels more or less 25, and the rest is the drive plus a little of aeroacoustics, okay? So this means that for a classical EMU running up to 200, the main contribution is still the track, okay? If we go to higher speeds, and for example, here I put an example of 360 kilometers per hour, which is, I would say, the highest speed we could reach today in test, but not still in commercial, okay? We could say that it's still the rolling noise, the main contributor compared to the aero. Of course, we're talking about how we measure the noise today. It's an average of a pass-by of the train, you know, the max level when a train passing by, okay? So more or less is that what I said, and what I was saying, that current measurement standards today doesn't show quiet trains, okay? What we do, the different manufacturers, okay, we always try to search for the best track to make our test, because we can see here that the track quality is going to affect a lot of on our performance. And I put here an example of, this is a simulation of one train simulated in just compliant track in terms of track decay rate and in terms of roughness, and compared to the same train measured in a typical TSI track, okay, what we could find, for example, from the deliverable of road-to-rail European projects. We can see that at 80 and 160, we have a difference of up to close to 5 dB of difference on the noise, sorry, on the noise performance of the pass-by of a train. And when we go up to 200, this difference is a little less because we have a little more of aero, but there's an important difference. So if I test my train in a very good track, I will show probably in the aero database that my train is, I don't know, 74. When if I test the train in another track, in a just compliant track, I will be maybe 78. So that will not reflecting the reality. It's not showing what is who is the quietest train. Okay. So in general speaking, I could say that for pass-by constant speed, we are close, okay, to the limit of feasible performances. So unless we want to change the technology and go do something totally different could be use of resilient wheels, but I think that nobody wants to listen about that for safety, okay? Then the rolling noise will be always at that level. And for parking noise, okay, the operating conditions is the key, okay, in order to in order to know what will be the performance of a train. I put here an example of what could be the different operating conditions in parking noise of a regional train, okay, depending if I'm in the rest condition, let's say the energy saving mode, in a rest intermittent because I need to turn on the HVAC to keep the temperature, or in the preparation for service when I need to prepare the train to be ready in the morning at 6 o'clock, something like that. You see, for the main contributors could be the HVAC transformer, auxiliary converter, traction converter, and main compressor, and the combination of different possibilities is quite complex. So for a supplier, predict how the system is going to work is really today a challenge. We're trying to improve on that because this kind of requirements, parking mode, we could say that they are more or less new, maybe 4 or 5 years ago, but it's very difficult to know how they will operate, okay? And here's just a small picture of the current draft of the ISO 13885 that is showing that the objective to understand a little parking noise is we need to, in this case is for winter, we need to keep safety temperature inside the train in order to have all the equipments working in normal conditions when we will work in the morning. And then we need to turn on the heating depending on the temperature outside. So this temperature and the temperature outside will mark totally the noise of the system. So if that temperature inside and outside is not standardized, we don't want to have different performances that will not be comparable. Okay, and what can we do, let's say, today to work on that? Mainly the noise of those equipments is 2 types of noises. Cooling noise, so all the fans, and the trend today is try to use what we call easy fans, so electronic control fans, so we control the speed of the fan in order to use exactly what is needed and not only 2 modes. And one complicated part is to improve the electromagnetic noise, because all those equipments, especially transformer, converter, and so on, they have different small transformer, different cells that generates electromagnetic noise, which is tonal. And when the noise levels are low, this can produce kind of annoyance, okay? So work on that, on the simulation of that, which is quite complex, because we have to understand that the sub-suppliers of those components, they don't know too much about noise. So we are in a world, let's say, of lack of knowledge for electromagnetic noise, and everything is based in measurements of reference equipments. So solutions to improve that is to increase the switching frequencies, because we know that when we control an equipment to higher frequencies, normally the noise radiated could be lower. And for example, this is the case when we use silicon carbon technology, that we can go to very high frequencies. Okay, we could use silencers, optimize the course of the transformers and so on. So this is just my presentation. It's just a comment to what was said before by Heike about the difficulties we have on the tenders, let's say, to improve propose innovation. I could say that today we are proposing more and more innovation on tenders. Why? Because our customers today, they really integrate in the tenders a technical score associated to noise performances, a bonus, economical bonus related to the noise performances, and a penalty if we are not able to reach those penalties. So at the end, noise today, I can give you one example of one recent project. Recent project was more or less something about 850 million euros. The overall bonus related to acoustics could be, if we were fulfilling all the requirements, up to 180 million euros. So that's a lot. So when you have a client, 180 million euros bonus for a project of 850 million euros. So it means that our customer says, okay, the budget should be more or less 850, but if you propose some improvements on the performance with some details on how many euros per dB, you could get a bonus when you present the tender, in that case, up to 180 million euros. So that's a lot. And when my company, all the companies, when they see that, they're gonna work, they're gonna tell you, what do you need to put innovation? So my suggestion to change that a little is to really from the operators to try to quantify in dBs and sorry, in technical score or sometimes in money, okay, those improvements in order to push suppliers to develop solutions really applicable, okay, to the tenders. More or less, that's all.